Hi, welcome to the lecture on bias. What is bias? Bias is one of the important terminologies which we use when we are discussing about the neural networks or machine learning. So often we are going to add the bias while creating any model in the artificial neural networks. Generally in a neural network, we have the set of inputs here x1 to xn. We have weights w1, w2, so on wn. So whenever we are increasing the weights, the increase of weight increases the steepness of the activation function, which we will be seeing shortly. So when we introduce the concept of bias, now the bias is used to delay the triggering of the activation function. Okay, we will see why it should delay the triggering of activation function and all in a short time. We already know that the summation function is nothing but x1 into w1 plus x2 into w2 plus x3 into w3 so on xn plus wn. Here we see the weight 1 as 1.0 into x plus weight 2 as minus 0.5 into x. So when weight 1 is 1 and weight 2 is minus 0.5, you see the activation function which is in blue color, so which is having the graph like this. So when you keep on increasing the weight from 1.0 to 1.5 and here from minus 0.5 to 0.5, the activation function is like this in the orange color. And in the last, if you increase the weight 1 from 1.5 to 4.0 and weight 2 from 0. to 1.5, the activation function you can see in the green color. So the more the weight, the earlier the activation function is going to trigger. So while we are keep on increasing the weights, the activation function will be triggering more earlier. So introduction of the bias, now it will be used to delay the triggering of this activation function. If you can see here, so this is the input 1 and this is the input 2 and these links are associated with weight 1 and weight 2, and now we are applying the bias for this one and this is our output. Okay, so now when you see here, we will see the change in bias. Okay, the weights w1 and w2 are made constant and we are going to change the bias values. So when the bias value is minus 1.0, okay, so the value of the activation function is like this, and the bias value is changed to minus 3.0, it is like this, which is in orange color. And now when you move on changing the bias value from minus 3 to minus 5, now the activation function curve is in green color. So here you can see that changing the bias is used to delay the triggering of this particular activation function. So in this manner, bias helps in controlling the value at which the activation function is going to trigger. So different values of bias allows the activation function to trigger at the different values. So now let's see the performance of different models without bias and with bias. So now you see here, this is one of the model where we do not have any bias here. We simply have an input here and we have an associated weight, and the output we already know that it is a function of input and this weight. Okay, so say this model is represented with an equation y equal to mx. Okay, we all know that the line equation y equal to mx always passes through the origin, where m here is weight. Okay, so here this model is having a constraint that whatever data it is going to fit in this particular model, the line must pass through only origin. See here, this model, whatever data it is having, it has to fit this particular data to the model in such that it satisfies the equation y equal to mx. But many times in the real world situations, it is impossible for a particular algorithm to fit the model so that it passes through the origin. So now we will see what happens if we introduce bias here. So now in this model we introduce a bias where the input 1 is x associated with w0 and input 2 is bias associated with w1. So the output will be w0 into x plus w1 into b. So instead of y equal to mx in the previous model, now we change the model to y equal to mx plus c. So now this value c is nothing but we are going to call it as bias. Okay, so now this y equal to mx plus c will give the freedom to this particular model to fit its data in any of the lines. So now see, It is having the full freedom to train itself to find a model which fits the best for given amount of data. And now we also know that bias is a constant which helps the model in a way that it can fit best for the given data. So finally, bias is a constant which gives the freedom to perform the model at its best. So I hope you guys have understood what actually a bias is, so why it is needed and why it is helpful. Thank you.